For number 6, what type of function is this? Absolute value or quadratic? Absolute value because it's a v. And if you think back to the parent function, so I know you have that drawn on one of your first examples, what changed from the parent function to this? It reflected, it flipped over the x-axis. Either one of those is fine. Down, I think it is fine. It is compressed. So because we're not doing horizontal compressions and stretches, these will all be vertical stretches and compressions. But yes, it did compress. With absolute value, it's really, I'll say once you get the hang of it, it's easy to see the scale factor because we can look and count the slope. So if you look at these points, what would the slope of that be? 1/3. And technically it's negative 1/3, but one side is going to be negative, one side is going to be positive, so that part doesn't really matter. We just need to know the number. How do you know it's what? Count up or down, so 1 and then over 3. And then that'll tell you that scale. So any of those definitions is fine. It got wider, it compressed. Really, we're looking at the scale. And that scale is 1/3. Reflect over the x-axis, would that be inside or outside? Outside, because it's vertical, it's doing this. Down 5 is vertical, so that's inside or outside? Outside. And this is going to be vertical. Anytime we compress a structure, it's going to be vertical, so that's also going to be outside. So now we can use those and write our equation. F of x equals, what would come first? The negative. And then we do need the absolute value, but there's something else that needs to go before that. We have the negative, the 1/3. Because that's your A value, and then your absolute value. And then -1. So especially when you have your scale factor, you may want to check this in your calculator, make sure the points match. So I'm going to do that really quickly. Negative 1/3 times the absolute value. Absolute value is alpha window if you're doing this. And then -1. And I'm just going to look at the table. There are a lot of fractions in here. I'm just going to focus on the whole numbers. So we have -3, -6. Accurate. -6, -7. 0, -5. And then on the other side of that should be 3, -6, and 6, -7. So we can say all of those things match. So we found the correct scale factor and all of the transformations.
So anytime the slope is not 1 at the right position?
Yes.
Okay.
Or actually that. Anytime the slope is not 1, it's stretched or compressed, and you have to figure out what that scale is. Do we have any other questions on 6? For number 7, what type of function is this?
Quadratic.
Is a quadratic. It is reflecting over the x-axis. What else did this do? Units. So then what did you say?
Oh, you already.
Okay. It did get narrow. So that would be a stretch. So that means we have to figure out the scale. For quadratics, to find the scale is a little different. You can look at the difference between the points and kind of compare them to the original. So in the original parent function, you need one of these, yeah. In the original parent function for a quadratic, it goes up 1 over 1 in both directions. And then it goes up 3 over 2 in both directions, up 4 over 2. But the difference between the points is usually 1 and then 3. If we look at the difference between our y value points, from our vertex to either of these points, there's a difference of 2 to the first set of points. So I would think the scale is 2. But then if we look from here to here, this difference is 6. It was originally 3. 3 times 2 is 6, so my scale factor is 2. The scale factor is 2. So if you look at that difference, and look at what it's doing, so if it got narrow, then it has to be some number bigger than 1. If it's compressing or getting wider, it would have to be something smaller than 1. And we'll do an example like that. So then using these things, we again have outside transformations, because they're all vertical. When we start to write this, what would come first? The scale would be in the front, but there's something else we need. The negative. We have the negative and then 2. And then the x squared. And the last thing? Plus
2.
How did you find the scale? So we see it's narrow, so it has to be some number bigger than 1. And if we are comparing the original, so I'm going to write this small table off to the side. This is your parent function, x squared. This is your vertex where you would start, 0, 0. And then it goes up to 1, and then it goes up to 4. So the difference on the parent function is 1 and then 3. On this, the difference between the vertex and either of these points is 2, not 1. So from 1 to 2, we'd have to multiply to get 2. And the difference between the second and the third set of points is 6. There's 6 units in between these. Usually it's just 3. So if I multiply 2 by 3, I get 6. And the same thing would work if it was 3. You would need a bigger graph to see all of those points, but the same thing would happen. Because then the difference would be 3 and 9. I am going to put this in the calculator so we can make sure that we did this correctly. We had negative 2x squared plus 2. We have negative 2, negative 6, negative 1, 0, 0, 2, and then it repeats. Negative 2, negative 6, negative 1, 0, 0, 2, and then it repeats. So those points are correct. So worst case scenario, you pick the wrong scale, you put it in your calculator, you check it, and your points don't match up, change your scale factor. You thought it was 3, maybe it was actually 2. Check and see if that works, and usually that's what it is. Number 8 is another quadratic. What happened to this one? Correct. We did flip, reflect over the x-axis. Left how many? 3. What else did it do? Moved up 4. Moved up 4. There's one more thing. Say that one more time.
Compressed by 1/2.
So I'm going to show you how you can find that also. Because you know it's gotten wider, it has to be a compression. You can still look at that difference that I mentioned earlier. So from the vertex to this point, the y value difference is still 2. From the second set and third set, the difference is still 6. So you would think 2, but because it's compressed, it has to be a fraction. So instead of 2, take that number and flip it, and it'd be 1/2. And if this was 3 and then 9, you would take that 3 and flip it, and it'd be 1/3. So then how would we write this equation? Negative 1/2. Here we have the left, so we're going to have stuff on the inside. X plus 3 inside parentheses. And then squared. And then plus 4. And then plus 4. Especially when you have things that have all 4, a stretch or compression, a reflection, a translate up or down, or translate left or right. When you have all of them, I would definitely check this in your calculator just to make sure everything is right. Negative 1/2. X plus 3 squared plus 4. Okay. Because it is 1/2, a lot of these are going to be fractions. You can ignore those points and just look for your whole numbers. So negative 7, negative 4, negative 5, 2, negative 3, 4, and then the point should repeat. negative 1, 2, and 1, negative 4. Which they do. So our scale factor is right, all of our transformations are correct. Do you have any questions on this so far? Come on. Okay.
First,
I think I had you guys write like a formula at the top. That A value, your scale, and your negative, those always go in front. They're outside also, but those always go in front. Your inside transformations, if you have a negative reflection, if you have a moving left or right, those would go inside the parentheses, inside the absolute value signs. And then anything moving up or down would go outside. So it's always going to be in that order. Negative first, if there is one. Scale factor, if there is one. Negative on the inside, if that's applicable. Left or right, and then up or down.
Also,
We're going to do an example with slope, but what was your question? Okay, so we'll do that in a minute. Okay, what type of function is this one? Absolute value. And what happened to this one?
move down 4, goes left 1, and it stretched.
Down 4, left 1. It was stretched. So we have to find that scale. So if you look at any of these points and count how many up, that would be 2 over 1, which would just be 2. So then how would we write this function? Absolute value.
X plus 1,
Inside the absolute value.
X plus 1, and absolute value, and then minus 4.
That is correct. Once you get the hang of it, it's not so bad. It's really just what happened, recognizing those transformations, and then being able to put them in an equation. After we do this last one, I'm going to give you practice so that you can practice this. Let's do this last one. This is what type of function? Quadratic. And what happened to this? Reflection over the x-axis. Went up 3. And it also stretched by 2 again. So how would we write this equation? Missing something. Negative, and then 2x squared. And this one, no, because reflect over the x-axis is vertical, so that's outside. Up 3 is vertical, so that's outside, and stretch, or your scale, is outside. So all of these are outside, so we don't need parentheses. You could still put them. You could do this. But that wouldn't change anything. We're missing one thing, though. Plus. There is a back to this, but that is your next lesson that we'll be doing tomorrow. So in this, do what you feel like you need. There are pages of practice, some quadratic, some absolute value. Find more complex ones, find ones that have scales, make sure you're good with all of those different things. As soon as I finish practicing this. Let me know if you need